Meg Blome. Whoops, I should say Dr. Meg Blome. We graduated from this department in 2004. She also has a minor in anthropology from W&M, and for her honors thesis, she did a really neat combination of anthropology and geology. She sort of continued doing that in grad school. In between William & Mary and University of Arizona, where she got her PhD, she worked on a Fulbright in Jordan, and then she came back to the States and spent a year working as an archaeologist. I think I have that right, in the DC area. Then she went off to the University of Arizona for her PhD. Then she moved into, believe it or not, the world of petroleum and worked for British Petroleum for several years. And she'll say a few things about that. And she's now finishing up her third year as a professor at East Carolina University in their geology department. So thank you for coming, Meg. All yours.
See if we can get this warning away somehow. Maybe. All right. Nope. Hopefully somehow.
Can you ask Chloe if she can?
Yeah. Chloe, are you able to remove that, or is that on my end?
Oh, what are you? I'm not seeing anything on my end.
Oh, something telling me that you're. Let's see. Can I get to it? Maybe.
Here,
There we go. Success.
Wait,
All right.
wait. Right now, I just see the blue background map.
Yep, we're back. We're back. All right.
There we go.
There we go. So, all right. Well, thank you very much for that introduction. It is a little bit surreal being back on the William & Mary campus, since the last time I gave a presentation was defending my honors thesis. So things have changed a bit since then. Yeah. And so really, I think it's fitting that I'm back here talking to you about the places that you may go based on some of my experiences. Although I gotta say, I've been following the William & Mary Geology Facebook posts about all the seniors doing really cool research, and now I want to hear from you guys about some of the stuff you're doing. So hopefully we'll have time for that after this talk. So we'll start with an outline of what we're going to be talking about today. And really the first sort of section of the talk, I intend to be a bit interactive. So hopefully you guys are ready. You're fueled with pizza and you'll be ready to share a bit. This first bit is really sort of what first piqued my interest in my very first geology class, freshman year, is that you can do geology everywhere. And in fact, geology affects you no matter where you are. So we're going to talk a little bit about that. And then we're going to head off to Malawi, which is where I worked on my PhD research. We're going to talk a little bit about some of the lead up to it, and then some of the field work that I did actually at Lake Malawi. And then we will dive into the oil and gas industry, sort of what types of science, what kind of roles geologists have in the business, and then also what you can do out in the field. And then last, we'll just very briefly touch on what I'm up to now. So hopefully, yeah, that should be about what we're headed to do. So for the first bit, I'm going to start with this quote down here in the bottom corner. Civilization exists by geologic consent, subject to change without notice. The first time I saw this quote, I was like, yeah, I guess that works. And the more I thought about it, and the more I sort of experienced geology through classes and then through working in archaeology as well, I was like, you know what? That makes a lot of sense. And surprisingly, I keep coming back to it in every place I travel, every place I've lived, every place I've done research. And now as I teach intro-level classes primarily, I keep wanting to remind folks of the fact that geology is important no matter where you are, and that you can do it as you walk out your door. There is something related to geology just outside waiting for you. And I think that's pretty exciting. That's what really got me going about when I started looking into this field. So what we're going to do for this first section is start talking about some of the things that can affect you where you live. This map I'm going to show sort of places I've lived, places I've traveled and done research since graduating from William and Mary. And so we've got on here, I'll use the mouse so folks can see it on the screen. This was Jordan, living in Jordan for a year, Arizona, Texas, and now North Carolina. And then these are some of the places I've gone to either explicitly look at geology or just happen to be doing fun things and noticing the geology along the way. And then lastly, places I've done research, some quick geoarchaeological jaunts to these two purple stars, and then some more in-depth research with oil and gas in South Texas and then Malawi for grad school. So like I mentioned, this first part is sort of, I want your contribution. So if we think about, remember that, that quote, what kind of local issues might affect you where you live that have sort of their basis in geology or earth sciences, generally speaking? So you'll, yeah, go in the back. Coastal flooding. Coastal flooding, yeah. So we are in both Eastern North Carolina as well as Eastern Virginia. Obviously, we are very much affected by coastal flooding caused by what? Hurricanes. And what else? The monsoon season. Okay, not so much, yeah. So Arizona and other places, but yeah. Okay, but coastal flooding, why else are we worried about coastal flooding these days? Maybe more so now than 50 years ago, yeah. Climate change, sea level rise, etc. Exactly, good. So some of the issues that are local issues and problems here, similar to the Gulf Coast in Texas, where I was, and now in Eastern North Carolina, very similar. This is, you guys were, it's like you knew what I was going to talk about. So this is from living through Harvey, which was fairly, I mean, amazing or awesome in the like true sense of the word, in terms of 50 inches of rain falling over Harris County, basically, in the course of 2 days, roughly. It was quite a disaster. That was my route to work for about a week. It was that flooded. We were out of our offices for 5 months, I think it was. And then of course there's the human toll, right? And the cleanup that happens after these big storms. So I try to convince, or many of my classes, I teach a lot of non-geology students, but I try to convince them that it's really important to have some understanding of earth systems in general, because it's going to affect you whether you want it to or not, no matter where you are. So the other places that I lived and I'm going to sort of draw in on is Jordan, so Middle East, and Arizona. So what kinds of things do you think might affect those regions based on what you know of geography? I know it's very different from here, yeah. Desertification. Okay, desertification, drought, yeah. What else? We're thinking sort of southwest to west over the last 2 years. What have we heard a lot about? Yeah. Overuse of aquifer. Okay, groundwater issues, definitely. Yeah. So if you're in a drought, you're going to get your water from somewhere, and if you've got an aquifer, great, you're going to drain that. What else? Wildfires. Thank you. All right, good. So yeah, it's like you guys can just read my mind. This is fantastic. So this was just an example, but this happens to come from about a year ago, 2021. Significant drought in sort of the Southwest, particularly the West. I mean, and the wildfires were making news, they have done for the last few years, maybe even longer. But if you have drought in January, you're gonna have wildfires in the summer, right? So summer storm season, or just people not knowing how to put out campfires and such like that. Yeah, you're gonna end up with, this is a smoke map, just an example smoke map from August. And I mean, that smoke, all those particulates and such made their way even to Eastern Virginia, right? So it's thankfully not the flames and such not affecting you here, but the air quality affected a good swath of the US. Good. So Yeah, and you guys also hit on those sort of water resource issues. We're gonna sort of in the global travel section, which is coming up, we'll take a look at some slides from Jordan, which are definitely along those lines. So speaking of global travel, so there's a reminder of that quote that I really like. So we're going to look at 4 different places of that, like that map that showed a bunch of different rectangles where I visited, focusing in on 4. But I'd be happy to talk to you about any of the others if you want. And what I'd like you to try to do is sort of see if you can tie some of these sites to sort of the history, the landscape evolution, and then any other questions you might see. Because really I imagine that anybody here traveled outside of Virginia? Okay, cool, great. Outside of the US? Okay, most people, okay, wow, almost everybody, I think. Great. What's the first things that you go to look at when you go travel? Or what's one thing you might go see when you go travel to a new place?
The landscape.
Oh, you go look at the landscape. Okay, great. Fantastic. Would you care to be more specific?
Well, does it go up or down? Is it bumpy?
Okay, so literally you're observing the landscape.
Does it
Okay,
have
good.
trees on it?
Okay. Right, all right. What kind of places do you go to? Yeah.
Stare at the road cuts, if I'm not.
Stare at the road
Maybe the wrong
cuts.
audience.
Yeah. No, that works. Okay. What else?
I like to go to the beach and go scuba dive, right?
There we go. We got a beach. Okay, there's a touristy kind of thing to do. Yeah.
I like going to museums and historical sites.
Okay. Museums and
That's what you're
historical
getting
sites.
at.
Okay, yeah, so that, but no, I was going the whole broad spectrum from landscape to road cuts, sure, to beaches, museums, yeah.
If they got an aquarium, I gotta go see it.
An aquarium, okay. Okay, good, interesting. Right. So yeah, you're definitely on the track that I was headed. So that's basically all of those things you said, or at least most of those things you said, are, whether you're going to see some historical site in a new place, right? So something that's become a tourist attraction due to its history, or the museums that's captured some of that information, or maybe you're going to the biggest city, right? Why is this big city there? Why did it end up there in the first place? You're going to go to some parks and go see the natural wonders wherever you are. So the landscape, sure, right? Why is that park where it is? Why is it important? What's its history? So so as we're going through this, those were definitely the questions that were going through my head, right? And so as we go through, we're going to start with here. So what kinds of sort of geologic history? This is in May, Memorial Day weekend or so, a few years back, on a glacier, sort of just a short day-long glacier cruise in Alaska. Which, yes, it was very interesting. It was actually really warm in Anchorage, and right next to the glacier, it was absolutely freezing, which was really cool. But anyway, so what kinds of either modern day geologic questions or concerns, or ancient sort of geology, sort of history kinds of questions do you have when you see this? Yeah.
How fast is the glacier?
Yeah, so that is definitely one of the modern day concerns, right? So glacial retreat. What else? How can that affect the humans? Why would we care from the human side of things? Yeah.
The rising in sea level, because all of that is going to get added to the general.
Okay, so that, yeah, just the fact that the glacial water eventually makes it to sea is going to affect people everywhere, right? Okay, good, yeah.
Well, and also in that area, the ice melting is gonna have the land rise a little bit.
Okay, wow, isosthetic rebound, I like it. We're getting some detail here, this is good.
Could impact local infrastructure.
True, right, okay, good point. Yeah, so then bringing you back to sort of the actual structures on the landscape, good. I know at least in, maybe not necessarily here, but in other sort of mountainous regions with glaciers, that might be some of their potable water resource, right? So the glacial melt, you don't have as big a glacier the next year, you're in trouble, right? So you're on. So yeah, good, fantastic. What a great audience. All right, so here's a trip to Costa Rica. This was actually spring break while I was in grad school, did this trip. It was pretty amazing. I mean, Costa Rica is not that big a country in terms of sort of geography, but man, it's got some really interesting landscapes. And I admit, I went with a fellow graduate student in geology, so we probably hit all of the geologically important things along the way. So what about here? What kinds of things might you see here? I was gonna say that too. Okay, geologic hazards, right? So we've got volcano, that's a pretty important hazard, good. Yeah, that can definitely, I mean, that's been affecting people positively and negatively through history, right? That's actually one of the things I really enjoy talking about in one of my classes is, you know, a lot of early civilizations actually started near volcanoes because of all the, sort of, yeah, really good soils nearby. Exactly, so there you go. But then, you know, when it explodes, that's a problem, right? So what's going on in the bottom left picture? Yeah, oh, sorry, go ahead. Yep, you.
Sustainable energy, so the wind turbines are.
Yeah. So, I mean, we're going to get to sort of the non-renewable resource side of things towards the end of my talk, but yeah, right. So how humans use the landscape now to capture energy is pretty important, right? Good. Yeah. All right. So here we go. Made it to Egypt. Hopefully everybody can see. This was some William and Mary Pride right there, right? So yeah. Woohoo! So again, this is sort of a desert landscape, at least now, but there was, you know, civilizations in this area for a very long time, right? Why? Why was this so such a great place for a civilization to build up? Yeah.
I would say that because of the Nile.
Yeah, because of what I'm standing right in front of there. Good. So like the natural flooding of the Nile, similar idea, you get really good agriculture along the edges. Yeah, okay, that's mostly what I wanted to get on that. Good. Okay, so now we made it to Jordan. And I admit there's gonna be more pictures of Jordan than anywhere else. But so Jordan, again, Middle East, most folks when they picture Jordan, they picture this, right? This is from Wadi Rum. That's also in Wadi Rum. But there are quite a lot of spring-fed water resources and sort of creeks and such there in Jordan. And you have evidence of sort of human history going back quite a while. This is pictographs in stone. This is Petra, where they literally were, the Nabateans were building their buildings into the rock itself. And then this here is actually, I'm standing on an ancient Roman road looking out at the Sea of Galilee. So again, the landscape and the types of raw materials people had all comes back to the geologic history of the area, which is so cool. All right, so now if you'll permit me, this was a hike that I went on last summer in Jordan. It is probably the most difficult hike I've ever gone on, but it was also one of the most enjoyable. It was 10 hours on this kind of surface. So sort of a scree surface. Headed from, we were originally at about that elevation down to here. And I was at the back taking pictures of all the really cool mass wasting and everything else that was going on. There, just in case you weren't sure, it really was me. But I mean, you look at this landscape and it's pretty barren, right? This was July, I suppose, right around there. And it looks like no water anywhere nearby. And then we made it to the bottom. Hallelujah. And there was fresh water and there was freshwater crabs scuttling about. It was really quite interesting and very refreshing. And that was what it looked like going through some of these bedrock canyons. I was also just amazed at some of these. This was like a debris, looked like a, you know, either one or multiple debris floods. So had to capture some pictures of these massive boulders. There's a 5-foot-ish scale right there, right? And some of these really interesting carvings. So yeah, success 10 hours later, bottom of the Wadi. But we went from, all right, I'm off the video. Went from this amount of water flowing through lots of freshwater organisms, marsh grasses and such, And then this is the floor of the water right as it enters the Dead Sea. What do you notice? Is there gushing water past my feet? Yeah, so this pipe back here, and I think maybe even there were a few others upstream, has captured the water that makes its way down to almost the Dead Sea and pipes it off to agricultural use or potable water use elsewhere. It's one of the reasons that the Dead Sea is shrinking. So anyway, I thought that was pretty interesting. I mean, it's this wide for a reason, right? And yeah, although most of that water is now captured and used, which is good in a place that doesn't have as much water to use in the first place, but it also has a negative impact as well. Yeah, that's also one of my favorite shirts. I don't know if you can read it. Geologists will inherit the earth. So that's that shirt. All right. Okay, so now we're sort of transitioning from sort of the modern landscape and current climate issues that we've talked about so far. And we're just going to briefly touch on two locations where I got to do a little bit of geoarchaeological work. One was in Turkey. So this was supposed to be a 3-week trip while I was in grad school. And we ended up being allowed to be in the field for about 4 days. There's a whole lot of paperwork problems, but we did manage to get a whole section of soil samples up through a nice sort of vertical section, like expected to be vertical section at time. And really the goal of the geoarchaeologist then is to recreate the landscape that the folks that made ceramics, for example, these sort of ancient peoples, I guess you could say, were living on, right? So obviously a really tight connection between landscape and human history. Another place, going back a little bit further in time, this is probably a Clovis site based on stone tools. This was in Mexico. And I only got to go out for about 2 days on this trip, but I was part of a class field trip to a site called Fin del Mundo in Sonora, Mexico. And it was pretty interesting. We found evidence of mammoth in association with some stone tools and debitage nearby. So that was a really cool little site. And one of our professors was one of the ones who found that. So, but obviously the landscape at the time when, you know, the mammoth belonging to that was roaming did not look the same as it did now. So starting to think about past environments and that connection to humans and the humans that lived there, right? Because the landscape at the time and the environment at the time definitely affected who was living there and why. All right. So now that we've made that connection, we can definitely see how it affects us today, right? And our current climate affects everywhere we're living today. There's no reason to think that it didn't also affect folks in the past, particularly because people in the past did not have the kinds of technologies that we have today to cope with, you know, extreme changes in temperature. So we're going to head off to Malawi and some of the work I did for my doctoral research. All right, so just to sort of wet our feet in this region, the very first part of my project began with looking at what research had been done in the area, looking at what climate resources there were, what climate records there were, and what we wanted to try and make a connection between the climate history that we saw and whether or not humans were living in certain types of environments. And so basically worked with a number of folks, including some paleoanthro colleagues, to look specifically at 60 paleoclimate sites, both terrestrial and ocean sites, so like ocean cores and things like that, from surrounding Africa, and then 70 archaeological sites. And we were trying to compare the dates of human occupation in those sites with what the climate records said was happening. Was it humid? Was it arid? Was it, what kinds of, was it cold? Was it hot? What was going on in terms of the climate record? And you would think that though some of these early humans, again, this particular study was looking at about 150 to 30,000 years ago, you would think that humans would be following the resources, which usually fairly well tied to water resources, right? There's sufficient water, sufficient plants, sufficient food, all the way up the food chain to the humans, right? So what we found though was that sort of a connection seemed to hold true as you went further back in the record. And yet, as you move forward in the record towards more present day, more modern humans, it seemed that folks were, the occupation of sites, they didn't necessarily abandon sites in times of drought, at least from the records that we had. So, of course, my anthropological colleagues were thinking perhaps they were able to, the folks that were, again, as you get, people were able to sort of deal with those changes in climate, either through tools or dwellings, other sorts of things that might have been able to help them sort of get through those times of harder climate. All right, so what we did discover from this though, is that although we had very detailed climate records in some places, very continuous climate records, particularly some of the offshore records taken from ocean basins, there was really a lack of continuous terrestrial records, particularly ones that went back pretty far in time. In fact, the most continuous record we had was sort of from the first chunk of a core from Lake Malawi. And so the rest of my time, pretty much the rest of my time in Arizona was spent taking a look at the rest of the core, the remaining 300 meters of core, to reconstruct the past climate in Africa over the last 1.2 million years or so. So that's where we're going to get to here. So the best way to make a continuous record of climate history is to have something where, like a basin, whether it's ocean or lake, but a basin where material is continuously being deposited, right? So a deep basin, the deeper the basin, the better, right? And if you want a terrestrial record, then a deep lake basin is a really good option. You should have continuous deposition, at least except until the points where you have, in this case, it was 600 meters water depth where the core was taken. So during times of drought or extreme drought, where all 600 meters of water is no longer there, then you would be exposed and subject to erosion. But at all other times, you'll have continuous deposition. So it basically acts like a bathtub in terms of lake level reflecting sort of watershed hydrology or history of the environment. And so if you've got really humid environment, lake should be deep. The different types of critters you're going to find in a sediment core will change. Types of minerals you'll find in the core will change. And then when the lake is shallow, similarly, different critters will be there as well. So what I was looking at in my work pretty much revolved around these guys. These are ostracods. I knew nothing of ostracods really until I started this project. Very little anyway. I still remember I had my roommate here, Elena Mary, did a project on ostracods. That was all the knowledge I had. So, but just like, so these guys are living in the sort of sediment water interface, benthic environment. And they will, just like other organisms, they have their preferred niche, right? They want their environment to be exactly how they like it. And if it isn't, they move away from the core site, right? So we were looking really at how these assemblages of ostracods change through time, and then times when there weren't any ostracods found in the core versus when they are can tell us something about water depth. So types of things that change in that sort of bottom water environment can include or actually just the lake water environment in general, but the bottom water temperature, where these guys live, dissolved oxygen, salinity, all of those things can affect these organisms. So what we did, and I'm not going to go through the squiggle plot, but just so you can see, there was about 300 or so meters. This is depth below lake floor. So 375 to 75 meters below lake floor was a section I was involved in. And it involved a lot of looking at sand-sized sediments. So ostracods are basically bivalve crustaceans, like shrimp-like things about the size of a grain of sand. And it's really their shells that get preserved in the sedimentary record. And their shells, thankfully, are distinctive. You can tell, at least down to the genus level, what organisms they are, particularly if they're adults, less so when they're juveniles. But again, each of these has a particular sort of favored environmental niche. And so we used this information with depth, and we're able to come up with sort of biological species. And we also included some of the mineralogy, and this is a sand size fraction, so we got some minerals as well, to make an interpretation of the different lake environments. So really, when you had a particularly deep lake, we found, or what we interpreted as a particularly deep lake, were times when there were no ostracods present. And then we had a couple of other sort of situations, relatively shallow, and then some sort of a river influence, depending on exactly which types of ostracods were found, as well as the sort of accessory minerals that were there as well. This was a lot of fun. It was a lot of microscope work, but it was really kind of exciting. But we also wanted to see if we could take not just these sort of known parameters that might affect where ostracods are living. We actually wanted to go out in the field. I desperately wanted to get to travel to Eastern Africa. So to do that, oh, I forgot. So one thing before we actually make it to Africa, what I thought was pretty cool is that some of the work that I did as part of my PhD work has continued to be worked on and continued to include my contributions. And as we've still been publishing on this work for the last few years, which is pretty interesting. This last bit was actually looking at some of the charcoal, which I haven't even mentioned, but charcoal being used that washes into the basin as evidence of how humans were affecting the landscape, like direct evidence of it. It's a really cool article. I highly recommend it. It's open source, go for it. All right, so back to what I was mentioning before, that I really wanted to make my way to Africa, and we also wanted to sort of see if we could see the same relationships between modern ostracods in the deep lake and these particular bottom water parameters. So are the relationship that we've interpreted based on the literature, can we see the same things in the modern lake? Now, the modern lake, as we said, is about is deep, right? It's a fairly humid time, even there in East Africa, comparatively. So we're not capturing the same sort of range of climates that the ancient lake has experienced. We're not getting that really saline environment. We've got a really shallow lake. But with that aside, we still got to go scuba diving in the lake. It's definitely interesting when you have to ask locals if they've seen any hippopotamus around or crocodiles before you get in. Yeah, before you get in the water. So, but this was our grab sampler, and then we also did some hand collection as well. But this is where we were at. We were in the southern part of Lake Malawi, and we did a bunch of different transects at different depths, collecting samples, and then looking at the sort of the shore environment. Was it a steep slope nearby, a shallow slope? Was there a river nearby? Was it just a marshy land, etc.? So we tried to capture, we also had various instrumentation for pH, salinity, DO, temperature, things like that, to see if we could really tie together what we were seeing in terms of the ostracods or whatever was in the sediment sample and actual sort of recorded water parameters. This was just some of the things that we looked at, including ostracods. I don't have them separated out by genus here, but we did divide them as well. And the biggest things was, okay, yeah, a number of ostracods decreased even at like 30 meters depth, which was actually a bit surprising. We weren't sure that we'd see it quite so drastically, but you can see about there, there's far fewer. Fishbone increased, mollusks were a bit more wishy-washy. And then this particular green alga that we had seen in the paleo core really seemed to increase with depth, and that was encouraging because that is also how we had interpreted it in the paleoenvironmental record. We had seen where we had a lot of Bachycoccus, we had very little ostracods or none. And so it was like, oh, this must be an indicator of deeper lakes. And sure enough, we really only saw it really sort of out to sea in the deeper lake. These were some of the variables that we found explained a lot of the variance in the model. And they weren't surprising. This was specifically ostracods. If you're curious about the other stuff, I have that as well. But dissolved oxygen, right? Important for critters. Bottom temperature. And then in here also is that sort of a shoreline environment variable in terms of what exactly was the shore doing? What was nearby? So anyway, that gave us a bit more confidence in our interpretations. Okay, so it may seem now that we've talked about sort of ancient, earlier, like really early modern humans, less distant modern humans, civilizations. Now we're going to jump into the oil and gas industry. You might be thinking, wait a minute, how is this at all related to anything you did for your PhD research? And you are correct. That it was quite a change to go from paleoclimate and sediment work to oil and gas. But because there are specialists that work in oil and gas companies, and typically they've done for their doctoral work, or at least master's level work, they've done something, they usually do work on like basin development, or how structural basins are formed, what happens to the sediments in there. Folks that really did like channel modeling for how rivers move through time. Folks who did work on like how seismic processing, things like that. So, or seismic analysis. So things of direct relation to something that is done in the field, those become specialists in the oil and gas industry. Then you have people like me who are generalists, and they are important too. So to work as a generalist, as a geologist in the oil and gas industry, you really need sort of a very solid background, a foundation. Give you a hint, you get that here. So really good foundation in geology, be able to think like a geologist. So quick to learn if you're taught something new, because you will be taught something new like every day. And then be able to incorporate what you've learned into what you are doing next. Key to this is being able to listen to others and being able to communicate to people in your own discipline and outside your discipline, because this is a business, right? And there's not everybody you're talking to is going to be a geologist. So in oil and gas, geologists you typically find in the upstream portion of the operations. That's basically finding the resource, figuring out how to get it out of the ground, and then once it's out of the ground, it's in midstream, and eventually when it makes it through refining and ends up going downstream, that's when it comes to your gas tank, for example. In the upstream section, you've got exploration, appraisal, development, and production. I did an internship in appraisal at Exxon, but my time at BP was spent in the development group. And the development team is geologists and geophysicists, right? So the geos, as we're affectionately known. Many people, not geologists or geophysicists, basically thought geos did everything, like they all did the exact same things. But we know that that's slightly different things. Those are sort of their roles. And then you have engineers. There were a number of different types of engineers depending on exactly where they were in the development team. But then we also had, it was important, particularly since the work I did was in the onshore area. You had to make sure you owned the land, or you had rights to the land that you wanted to drill on. So we had legal sort of land team. Finance, right? Again, business. So folks that are following the money, and then a leadership team to help us make sure we're all on the same track, working with the same goal. This was my focus, right? The geologist's focus is the rocks and the sort of this pore space within the rocks and what fluids fill those pore spaces and things like that. And I gotta say, like it took a shift in thinking to go from caring about like the sort of the rock history, the sediments themselves, to caring about what's between them, like between the sediment grains. That was fun. I quite enjoyed that. So through sort of the last 100+ years, I actually really like this figure. It shows sort of how the goals in oil and gas production have changed from what we call conventional resources, so high natural porosity and permeability. In this sort of situation here, this is where you would stick a straw in the ground and you get a gusher, right? Something that flows very easily on its own. You don't have to create permeability. Maybe not a gusher in every case, but that's the example that I picture in my head for early high porosity or high perm environments. And then we get, can I close that? No, can't close that. All right, fine. And then we get what you can't see under there. It says low permeability. So low permeability environments are your unconventional plays, your unconventional resources. And these are things, as it says, low permeability. So something has to be done to the rock to release the resource and allow it eventually to have enough space and connected pore space to flow to the well. It started really early, still had vertical wells accessing these tight sands. And then sort of much later, you ended up with, not much later, 10 years later, ending up with these horizontal wells. And most of the work that I was doing was with these horizontal wells in shales. Now, I don't know how many of you have actually been out in the field and you've held a shale, a piece of shale, right? Or exposed probably in the labs, held a piece of shale. Does it look like there's a lot of porosity in that? No, there's not. So I'll show you a picture here in a second of an outcrop view of the same stuff we were drilling. And you could take a piece of it and break it off and you'd smell what smelled like a gas station. I mean, it was really interesting, but you look at it and you're thinking, no, just looking at it in hand sample, how is there fluids flowing through this? Anyway, so low permeability, the more there's certain properties of these rocks that actually made them better or worse for drilling. These are examples. This is a geology shop. We gotta show you some actual rocks. So tight sandstones. Tight just means low porosity, low permeability. So here's an example of a pore taken there, and this is the shale. So this was pretty much similar to what our target would be in these horizontal wells. The darker the shale is, the more organic rich, and assuming it's gone through the right baking process, the more potential it has to contain hydrocarbons. So what's interesting though is we had to look for a good balance between having a lot of sort of original organic matter, which tends to make shales a little bit squishy. It's hard to think of shales and squishy, but go with me. And something that had enough brittleness that it could be fracked, that you could actually keep open a frac to allow the well to flow. So I was working here for a good portion of my time at BP, and this is the Eagleford Shale. There's a lot of shale plays, potential shale plays in North America. And luckily, our team had about a couple hundred kilometers from where we were accessing this resource in the subsurface, there was actually an outcrop of the exact same rock. Now it's, okay, I say exact same, it's at least the same formation. It's not the exact same, but it was it was better than even just using a sort of a generic shale analog. It's the same material, just up section, basically, or up dip, really. And so what we could do was tie what we saw in this outcrop. Someone actually drilled a core from the top of that all the way down and took the same kind of logs that we would take at a well site and compare them and the lithologies and everything else to what we had in the subsurface. And you collect a lot of data in there. Now specifically, the data that you collect has to have a business goal, but it's still a lot of really cool data that you're able to collect and work with. You get these electrical logs, you get core rock and the various parameters that you can deal with that, porosity, etc. So the goal from all of this data collection, including the rock, that was the best part, was getting to go out and collect rock, actual core or sidewall cores. But the goal then is to choose the best target to land your horizontal well. And we often got, well, I wouldn't say we often got pushback, but occasionally we would be asked, why does it matter where you land your well? You're just gonna frack the heck out of it anyway, right? And these fractures might go in all sorts of directions. And you're gonna be able to get all of that rock anyway. No, not quite. So it was still important to try and land in the best rock, because you wanted your best rock to be what you most accessed, right? So the highest probability of success. But this is sort of what you would geosteer. So someone, even actually some folks with bachelor's degrees would go out and work on the well as a geosteer. So you don't necessarily have to have master's or doctoral degrees to go out and be part of this. We tried to figure out where you were, where was the driller, and tell them, all right, this is the time that we want to kick off. All right, so based on where you landed it, that's part number one. Then you have to frack it. And this has involved a lot of really close work with the engineers. I learned more about engineering in the time I spent, particularly working in Eagle Ford, than I ever had in the previous 20 plus years of my life. So it was actually quite a lot of fun, very interesting. Keep coming back to, actually, this was a quote from one of our engineers who was arguing that no, it still is really important to have geologists on the job. I'm like, yes, because even if we're landing in these shales, which originally everybody thought was exactly the same for kilometers and kilometers and kilometers, didn't matter where you were. He's like, no, we can, having what we do, the engineers do, can really screw up a well if it's not sort of fine-tuned to the right properties that we give them. So I thought that was, I was very encouraged that. Not that I ever threw that around the office or anything, but yeah, like don't forget we're important. Okay. So yeah, so takeaway from this is that it was a collaborative effort. I think this was our engineer, and these were two of our interns one year, and that's me. So out on the well site. It is important to remember, of course, that, again, you can't see it in here, sorry. So it says at the top that oil and gas is a business, right? So this is price of oil through time, the last decade. And that's when I was hired. Pretty good time to be in the business. That was the first set of layoffs that I lived through. That was the second, and then that's when my team was cut. And there was another layoff after this, but I wasn't there anymore, so other people got to deal with that. And it's, it's not only depending on the price of oil. That's mostly affecting folks working offshore, the Gulf of Mexico kind of area, or North Shore in Alaska. But what we were concerned about, we were working a lot of natural gas plays. So that's when I was hired again. That was the first set of layoffs, second, and then that's when my team was cut. So, there is that up and down of working in a business like that, but while you're there and while things are good, it's a really interesting place to be. And I know this wasn't a job type talk, but other types of jobs other than job here. Okay, speaking of jobs in academia, very last bit to just let you know what sort of how I've transitioned now. I basically realized that I was doing some teaching as a volunteer for fun and said, well, maybe I need to really switch plans, switch goals after the layoff that finally got me. And so I've been at ECU now, like as Brent said, for about 3 years. I'm finishing up the 3rd year. Go Pirates. And even during COVID, we managed to make it out to a stream that's just down just a couple, I don't know, half a kilometer from the campus. This was my intro group out there taking a look at stream processes. This is actually a stream cut of the Yorktown Formation. So it heads all the way down to North Carolina. And these folks were looking at unconformities and various fossils. And anyway, I've sort of made it to the point where I'd like to contribute to that next generation and get folks as excited about the relationship between geology and everything they see when they walk outside. And so that's what I'm doing now. Thank you. Any questions? It was a bit sporadic in the talk types, but
There was a picture I didn't understand. That was the one at, showing the pyramids and the image up in the upper right-hand corner. I couldn't understand what that image was.
okay, yeah, I did sort of skip over that a little
Yeah.
bit. So the picture from Egypt, I can go back to it.
Yeah. I think that was tree roots. It was
So
precipitation of something like.
it was sorry, I'm almost Mac illiterate. So here, let me get to it. So this, yeah. So I was going to talk more about. I got carried away on other slides, but
It wasn't that.
So
one, it was
that's-
another one.
oh, it was the other one?
Oh,
Oh, that's Costa Rica.
Yeah, it's Costa Rican cave.
Yeah. So yes, sorry, this was a cave.
Oh,
It's a cave
okay.
up at the top. It's a little hard to see now with the lights, but yeah, I'm claustrophobic, so going into the cave with my colleagues, my classmates was a lot of fun. Learning how to scuba dive, also a lot of fun when you're claustrophobic. So yeah, but yeah, it was more just to show that there's sort of such a wide breadth of, like I said, Costa Rica is not that big a country.
Right.
There's massive, like crazy amounts of different types of landscapes to look at there.
Thank you.
And I didn't end up mentioning the part about Egypt, but this was, I was actually standing on the Aswan Dam, and there was a reservoir behind this where they pulled up the Nile to help serve as a resource for water resource. And then of course, then you've got locks on the Nile now. That's what that was trying to show. Yeah. I'll always talk about places I've been. So I cut out a bunch of places too. Yeah.
I guess it's kind of more archaeology, and I don't really know how to phrase it well, but
Sure.
what sort of did you ever do like a formal like archaeological field school, or did you not really have to do that because you were more geo focused and did more geo field work sort of things? Or?
Nope. Well, I did actually do an archaeological field school with Martin, who's on the call, but we did a field school up in Hanover County, near the, it was right off of the, I almost still remember the site number, but yeah, I did the 6-week field school in the summer.
Did you do that?
Yep, it was awesome. Highly recommend. If anybody's an anthro minor, go for it. I think there's, I don't remember exactly what the prerequisites are for it, but it was great. Great way to spend it. It was a hot summer though. So I remember shoveling through river gravel. Yeah, Brett.
I asked you this question earlier. The rest of the audience might like to hear your answer.
Sure.
That is, now that the price of oil is back up, if they ask you to come back, would you?
Put me on the spot.
Great money.
At this point, probably not for me. I think it's potentially a good opportunity for others. Folks right out of school, folks right out of grad school in particular. The majors typically require geologists. The major companies require geologists to have a grad degree to start working, whether it's a master's or a PhD. but a number of other companies don't. You can come right out, work in the field. You can be a mud logger right out of your bachelor's. You even don't necessarily need a bachelor's. So there's ways to get into the oil and gas business without having to necessarily go to grad school. And with oil, the price that it is right now, it might not be a bad place for folks to get their feet wet, earn a little money. For me, I like the slightly more stability that I have teaching. I like getting others excited about it. Yeah, so not necessarily for me. No. It would have to be a really good offer. So I'm not, but it's, you know, it is market dependent. So you have to be okay with that risk. Good question. On the spot.
I have a question.
Yeah.
For the 10-hour hike, was that one way 10 hours?
Yes, it was. We did not hike back out of the wadi. No, it
Okay,
was.
that was my question. Like, how'd you get back?
It was 10 hours. Well, luckily the bus that dropped us off at the top met us 10 hours later right by the Dead Sea. It was 10 hours one way. It is surprising how difficult that scree surface is to walk on when you only brought regular tennis shoes. That was my mistake. Having hiking boots would have helped a lot. But I had not planned on that trip before packing for the trip. So yeah, that was 10 hours. It took about 3 hours just to get down, and then the rest of the time was actually hiking within the wadi, more or less at the Wadi Valley floor, but you're going over boulders and everything else in there. It was fun. Like I said, I was distracted looking at the geology. Good question. Thankfully, we did not hike back out. Yes. Yeah, Rowan.
So just for everybody's sort of knowledge here, when you came to William Mary, what were you thinking about originally majoring in? And then when you left William Mary, what did you think you were going to be doing for the next 5, 10, 15 years?
I was an intended archaeology major until I took Chuck's class my freshman year. So that changed pretty quick. I don't remember. I thought I was going to do. Actually, my project that I thought I would do when I got to Arizona was looking at. I wanted it to be a specifically geoarchaeology project, trying to look at migration of hominids from Africa through the Middle East and onward, because I wanted to use the Arabic I'd studied if I could. And then I realized how long it takes to get a project funded, and ended up on a different project. So still got to be sort of past climate, geology, archaeology, but it ended up being a completely different project. So yep, you will end up, I imagine most of you will end up taking a fairly circuitous route through your careers. So, and what you study for your undergrad versus your master's versus PhD may have everything or nothing at all to do with what you end up doing for a career. So, yeah. Any other questions?
Any other questions for me? Well, thank you again. That was fun.